Hi, good morning, everyone. Hi, Ian. Hi, Noel. Three of you are still not here, so it's okay. We will continue with our lecture. So for today, we will have our lecture in the morning and your practical test in the afternoon session. So yeah, so this is our chapter, our current chapter. So yesterday we already start with 4.2. So for chapter 4, we have two part, 4.1 and 4.2. So this is the last part of chapter 4. So 4.2, network operations, background operation and mobile server operation. So this is the objective. You already go through this objective yesterday. Understand mobile server communication, background operation, network operations, and mobile server operation. Okay, so this is a mobile to server communication. Communication from our mobile to the server. How they pass the message or data through the network. So for communication from mobile to server, we need to have this API. API is like a platform. Okay, so API is the application programming interface that we use for the communication between this front end, the mobile. Front end is the mobile here, and the back end. Back end is, for example, is the server. Okay, and then we have this mobile system architecture. So front end and the back end. So front end is basically, as you can see from down here, okay, as you can see what is front end, what is back end, as I already explained yesterday. Front end is basically what the user see or operation activity that the user can see at the screen, and back end is this process. Okay, the network. Network here can be what network that they are using. And then the API server. API is the platform that I said just now, platform for communication, and then your DB server and your cloud DB. Okay, and then here you have your local DB. Local DB is at the user's device. So do I even need a backend for a mobile application, for a complete mobile application? Yes, you need to have a backend, unless it is just a prototype, no process, no function. It's literally a prototype, only like a non-working button or even a broken link. That one is only a front end. So if you want to make it work for your mobile application, for your apps, yes, you need to have the back end. Back end is basically including your DB, your network, your connection, your API, all the process. Okay, so now in this part, we are going to see the protocol. Okay, this one is mostly the network protocol, communication protocol. Okay, communication here is referring to how this front end, how the user or yeah, the interface transfer from this back end or from this front end. Okay, so methods to communicate, we have SOAP, REST, and XML RPS. Actually here, for this method, for this method, actually it's a bit it's not a bit complicated, because we need to do some setup, we need to use some token, because I remember I used this one last time for API. So, okay, so this one can be an issue too. Okay, doesn't mean when you develop your mobile application, you know how to connect this one. Okay, this is like another knowledge that we need to learn, how to link this front end with this back end. Okay, so REST XML RPC is the API. So here between this front end to this API to this back end, we have this HTTP. Okay, HTTP is our protocol, one of the protocol. Okay, and then we have machine-to-machine communication. What is machine-to-machine communication? I already explained yesterday. Machine-to-machine communication is the communication between one device to another device. Okay, so representation, we have this REST, representational state transfer. Okay, so for REST, they supports few types format, which is HTML, XML, and JSON. Okay, HTML, XML, and JSON is mostly we use at the front end. JSON JavaScript object notation. This one is not the Java. It is not the backend language that we use. JSON is not complicated as Java. Okay, it's a simple, it's like simple, yeah, simple text format. That's why we use at the front end. So inherits HTTP operation. That's when they apply, they have this operation, which is get, pause, put, and delete. This is a method, operations that here. Method that we have in HTTP, get, pause, put, and delete. Of course, each of these, they have their own function, purpose. Okay, so now here is SOAP, Simple Object Access Protocol. So they support SOAP, they support XML. Okay, XML is one of the language. Okay, but to use XML, we need to plug in into another language. For example, PHP, and you can use it with HTML as well. Okay, so SOAP, they support XML. So they have few application layer here: HTTP, SMTP, TCP, and UDP. Okay, so yeah, this is where I need to refer my note. This is networking, right? Okay, so TCP here, HTTP, SMTP. So SMTP is Simple Mail Transfer Protocol. TCP is Transmission Control Protocol. UDP is User Datagram Protocol. So usually they will have, if you go to Google, because I did Google this protocol, these two protocol, usually they will do comparison between TCP and UDP, these two protocol. Okay, UDP is faster compared to TCP. Okay, and then UDP is up to date compared to TCP. So this is the format for these two file document. Okay, so for XML, like I said, XML and JSON, we use this at the front end. So we can, actually for front end language, if you know how to write or how to read one programming language, for example, PHP, HTML, CSS, XML here, if you know how to read them, it will be easier for you to understand other front end language as well. Okay, because usually they plug in, there's like we plug this one programming front end programming language to other language. So here, that's why you see the pattern is like, of course, they have different syntax, different format. However, it is almost the same. So this is the format for XML and JSON. Like I said, JSON is not complicated as Java. Next, we have this SOAP data format. Okay, so this is the example of SOAP data format. Yeah. And then Android JSON parser. Parser is a compiler. Parser is a compiler or interpreter that we use to convert one language to another language. So most Google APIs are available at JSON REST service. JSON is faster and easier than XML. Android use the JSON object to read the JSON stream. So here, I think we stop at this. Is it here? Yeah, we basically stopped at this part yesterday. So here, man versus background thread. Okay, so this is, actually we stopped at page 15, but this is the start. So man versus background thread. Okay, so there's two different thread, and then we cannot, this operation, okay, cannot be implemented in the same time. So here, the one I mentioned just now, man usually it will be the UI thread, and then the network operations is the background. Okay, so UI and network operation should be implemented on different thread, different process. Okay, so Android throws a network on main thread exception if you perform network operation on UI. Okay, so this one is like an error. Okay, if you perform this network operation and the UI, so it will throw this exception because as stated in the first point here, should be implemented on different thread. So you cannot perform the network operations on the UI thread. So there are two types here, like I said just now, main thread. Usually it is the UI, the process, and then the background. Background here is the network operations. Okay, so this is, yeah, so this is where we stopped last week, last class yesterday. So main versus background thread. Okay, we split them into two because they cannot implement here. They cannot be implemented in the same thread. Need to split separate. So we have UI. I think UI here should be user interface, not the user interaction. Okay, user interface is our main thread, and then the long running operation. Under the long running operation, we have this background thread. Okay, long running operation is operations that return a response where they have a request. Okay, long running operation where they have to perform a synchronously operation. A synchronously operation, that means it is a operation that will be performed on a different time. So here background thread, we have the code bitmap, this IO input output, and your network. Okay, network IO. So here is the background solutions. Okay, so here as you can see, we have download manager, foreground service, work manager, alarm manager, web manager. So this one is like the sample. So we're going to check on the first one, first network IO. So under this network IO, this is like a flow chart. Under this network IO, okay, so if it is yes, so this is the example of the operation download manager. So now or never, so this one is the example of this level, and then depends on the system condition. So if yes, depends on the system condition, this is the example, work manager. So run a specific time. Okay, the example is alarm manager. So if it is not between four of these, it is the work manager. So this is it's like a flow. So this is the example of this process. So this is the explanation. Okay, from this flowchart just now in the previous slide, background solution. So you have this class, okay, and the description. We only have 4 here. So the first one is download manager. Okay, so for download manager, it's perform long running HTTP download. Okay, long running HTTP download. So you need to have your network IO first to perform this class download manager. And then next is foreground service. So user initiate work that need run immediately and must execute to completion. Foreground service. And then alarm manager. So alarm manager is like the term here, to do the job at the time you specify under specific time. And then work manager. It runs deferrable background work when the work's condition like network availability and power are satisfied. Deferrable is like something that we postpone. Yeah, something that it's not that here in this context, that means this is any operation that postpone until they meet, for example, here the network availability. Okay, any operation that they postpone until they have this network availability. Okay, so this is the class and the description for each of this class for the background solution. Next, we have transferring data via network. Okay, Kotlin is the language. So use work manager core routine. Core routine, I think I mentioned yesterday. Core routine is a concurrency design pattern. Okay, concurrency design pattern that we can use to simplify our code. So here we have this sync adapter. Okay, sync adapter, core routine, sync, that means it is concurrent together. Yeah, they perform the execution of the code synchronously, concurrently, to transfer of data regularly and efficiently, but not instantaneously. Okay, together synchronously, but not instant. That means there's a delay in the process. There's a delay in the data transfer. Okay, so here connecting to the network. Network here is the source. The source. Okay, so we need to have permission. We need to write or declare a permission. So here use permission, internet, and then this is the permission that I want to ask, the to access network step. Okay, so network communication best practice. Minimize the amount of sensitive data that you transmit over the network. Minimize the amount. Okay, not necessary you cannot perform or you cannot transfer any sensitive data or high risk file. Okay, but actually we can do some like step. Oh, there's this one. We can do like some prevention. Here they ask to minimize the amount of sensitive data due to the security purpose. Okay. For example, security threat is like hijacking to the network. That's why they ask to minimize. Actually, there's other method to counter this situation. But yes, here, minimize the amount of sensitive data yet that you transmit over the network. Okay, any file with the sensitive data. And then so send all network traffic over this SSL, secure socket layer protocol. Next is here, determine your status of your connection, your network connection. So use the connectivity manager to query the active network and determine if it has internet connectivity. Okay, first you need to check for an active network. Okay, any network that is available, and then if it has internet connectivity to, for example, to transfer the file, to transfer the data. Okay, so here you're going to check the connectivity. You're going to check any active network. You need to check the active network. Okay, so here they're going to check the active network with the info, and then they're going to check if it has connection, internet connection. So here, if true, then yes, it is. Then if no, then it is not. So only if your value here is true, then they will proceed. Okay, they're going to check this connection first. Sorry, they're going to check your internet connection first. If you have the internet connection, then only they go to do the process. Yeah, connecting to the network, the internet connection. So here, the network connection. I think actually for this part, some part of this chapter, you guys know better than me, just networking. So here, network connection. So network operation can involve unpredictable delays. This one is due to many reasons actually, many reasons. In networking, there's many reasons for the delay. Okay, network operations. Network operations here, for example, just now I said, we want to transfer data with a file. Okay, so the transfer is the operation. So sometimes the operation to transfer the file, we will encounter with delay. So perform network operations on a separate threads from the UI thread. Okay, this one is the first point just now. Okay, we need to separate these two operations, network operations and the UI operations. So use the async task. Async task, that means it is async task. Different task, different execution time to perform network operation. Oh yeah, this one is the second point just now. Okay, use async task to perform network operation because we need to separate from the UI. So it performs background operations and publish result on UI thread. So here, okay, so here is a process actually. So here, as you can see, we have this UI thread and the background process. Okay, so here on the first one, UI thread, okay, we have this pre-execute the process, and then under the sync task, the background process, we have do in background process. Basically, there's a process inside this phase level. Okay, it's a background process, and then the post the execute. This one is after this process that we have in this phase done, then they will go for post execute. So here we have this main activity and then the sync task at the background activity. So we have this network fragment. Fragment here can be Fragment is like the activity. Okay, so network activity. So first, download task. This is the task that I want to perform from network to the background. I want to download. Okay, so I send a request to this background to download. There's a process, like I said, at the back end here. So I send a request to do the download, and then they do the process here, they return this statement, download callback. Okay, as you can see, even from page 29, they split these two operations, the UI and the background. Okay, so next, async task. So up to this page, is there any question? If no, please raise your hand. Okay, thank you. So async task. Okay, subclass. Oh, sorry. It must be a private subclass. For async task, this is not our main class. It is a subclass. Okay, override at least one method. So this one is method. This one is the example of method, the function, do in background, and this is the parameter inside your function. So often we'll override on post execute result. Okay, this one is suitable for short operation. Just now I mentioned about long operation, but for async task, it is only suitable for short operation. So this one is a process to convert the input stream to a string. Okay, so input stream is a readable source of type. So you can decode or convert into targeted data type. Okay, conversion. So here is the input decode stream. So download an image and display. Where's the, okay, so conversion of input stream to a string. Okay, that's mean you want to decode or convert it into any targeted data type. So here is the process where you are going to do the conversion into any data type that you want. Okay, decode stream, conversion input into a string. So this is a question one. Oh, Kelvin is not here. Okay. So this is the question. Okay, explain the relationship of these three main components of the mobile app, API, and backend. So this one is at the first part of this chapter. Okay, the mobile app. Yeah, the component of the mobile solution. We have mobile app, we have API, and then we have this backend. So here you need to explain what is mobile app, or what is the purpose of API to this mobile app to this backend, and what is backend. Next, sorry, for question one, this is Daniel. So you need to explain the mobile app, API, and the backend. I've explained this one. And then why a mobile app should not implement network-related tasks on the UI thread. Okay, like I mentioned in this chapter, this thread, the UI thread and the network thread should be separated, cannot be performed in the same thread. Why these two activities need to be separated? And then explain the use of async task in the network operation. This one in the question number 3 here, actually in the page 23. What is the purpose of async task in a network operations? So question 1, Daniel. Question 2, Kelvin. Question 3, Wong. Wong, not the Solomon. Yeah. Actually, I do not know how to pronounce your name. So I give you until 9:35 for this question, Daniel, Kelvin, and Wong. Alright, so I think only the first answer. I'm not sure, Daniel. Either he is AFK or he's still sleeping or maybe diving, but it's okay. I'm going to explain the first question here. Okay, so explain the relationship of these three main components of a mobile solution, which is the mobile app. Mobile app here is your UI process or the activity. Okay, so this is the component, the mobile app, what the user see, what's the process or what activity on the screen. And then API. API here is UI and mm, all the process, all the process, all the process. Can I see all the process? Yeah, so for the first one here, okay, three component of mobile solution. First, we have mobile application. So this is your UI thread, your process, and then your activity. Okay, so for the API is a platform for communication between this front end and the back end. So here, example of API, just now we have SOAP, REST, and yeah, I just remember these two, SOAP and REST, okay? A platform for communication between the application and then backend. Backend is any process that related to your network, DB, and the server or etc. So basically, this is the relationship between these three components. Okay, so next is second question, why a mobile app should not implement or why we should separate this network related tasks on the UI thread. Why? Here is the example. Sorry. Here is the answer. Okay, so Android throws a exception if you perform network operations on the UI thread. Okay, however, why they throw this exception? Why they throw this exception? It is because this network process will actually block the whole UI process. That's why. So the answer here is correct. It will throw this exception. But what is the reason why they throw this exception? It is because any network related task, it actually block the whole UI process. That's why it will return this exception. Okay, so this one is correct too. This one is only like the reason why they throw this exception. Next, the third one, explain the use of async task in network operations. Okay, so this is a task. Thank you, Daniel. So number three, explain the use of async task in a network operation. So it is a task that perform background operation and sends the result back to the UI. So for example, when these pre-functions call these background functions, it perform the background process or operations and call back the post function to update the UI. So basically, this one is in easy explanation. Explain the use of a sync task. It is to ease the use of the UI thread. Okay, this one is the answer, whole statement. But I summarize this answer to this statement for proper and easy use of UI thread. So this one for question number 1. Question number 1, we have an example of the process. Okay, example of this process for this main component, your mobile app, your API and your backend. So this is the process. So mobile app will request API server from mobile client through the network API through the network, and then API receive request from mobile app. And then backend handles the data from the mobile application. Yes, actually his answer is correct. You can relate his answer with the answer that I provided here. Okay, so your application, of course, they will send a request to the API. Okay, like I said and I explained yesterday, I think. I said our mobile application cannot have direct communication to the backend. The backend also cannot have directly send anything to our mobile application. That's why we need to have this API. Okay, I call API as a platform for a communication. So here in this context, it is a platform for a communication between your app and your backend. Okay, so your API receive request from this mobile app. So this API actually will send this request, and of course they will process the request first before they send to the backend. So once the backend already receive your request from this API, they will handle the request or the data from the mobile app, and then they will actually process the request and send it back to the API. To the API. Okay, so the API will process and then send this result to the mobile app. Okay, so that's the process, or that's the logic, the flow of our API, the function of API. So remember, we cannot have this communication direct communication between our application here. So this one is for the first question of today. So for the first question, is there any question? Can I move to the next slide?
No.
Thank you, Noel. So yeah, so find out more. Okay, so this one is any additional reading for you, the link. Okay, perform network operation and perform operation using Coronet. Coronet actually is Coronet. This one is like a networking that is, it's like a protocol. No, it's not a protocol. It is for the mobile application networking. Okay, Coronet stands for Chromium Networking Stack. Okay, Chromium Networking Stack. I don't remember what it is stand for. However, it is for the networking of our mobile application, connection of our mobile application. Okay, so now here we have Volley. Transmit data using Volley. Volley is like a library, yeah, stated here. Volley is a library. Okay, Volley is a HTTP library. So it populates data to UI, the main thread, and display the search result. So this is not suitable for large download or streaming operation. Yeah, it's not suitable for download or streaming operation because actually during the process, this this library actually holding the data. Okay, they're holding the data through the process. That's why it is not suitable for any operation, any big or large operation. So this library support string, image, and JSON. So benefit of this library, it is automatic scheduling of network requests. That means we can schedule, we can set time, or we can schedule the time when they want to send the request, network request. And then multiple concurrent network connection. Multiple concurrent, that means they have more than one connection concurrent together in the same time. Okay, they can have more than one network connection at one time. And then the support for request prioritization. That means we can also set our request if we have a high priority. Yeah, high priority request. We can set our request as high priority, medium, or low priority. So they have this function, request prioritization. They are going to, of course, the request with higher priority, they are going to process first, and then support cancellation of request. Okay, once we already send the request, we can do this cancellation. We can roll back our request. Okay, so include library. So you need to add the following dependency to your app build Gradle file. What is dependency? I think in our lecture yesterday, I did explain what is dependency. Dependency is anything that we need to support our function, anything external that we need to support our function. So here in this context, we want to use this library. Okay, so this is the dependency that we need. So we need to implement this in our code. So implementation dependencies to support. So yeah, we said that we want to include this library. Okay, so this is a URL for you to see how to use this link. So here, just now is a library. So now we are still in this library. However, how to write a standard request, how to send a standard request. So we have request 1, 2, 3, and then the description. So this library support the following requests. Okay, string request, string. I think the term here, even from the term, you know, string request, retrieve a raw string in response. That means I want to request a result in string. Okay, retrieve a raw string in response. And then JSON object request, retrieve a JSON object response, and then same with this one, request for JSON array. So retrieve a JSON array response. So here actually, I think maybe if you are already familiar with the Kotlin or the programming language, actually from this request here, what is the result that we will get? Okay, string request, return string, just JSON object request. We will get a result in this form and then this JSON array. Okay, we will get the response or result in JSON array format. Now we're going to see at the first one just now, string request. So it will retrieve a raw string as a response, as a result. Okay, so this one, okay, so initiate the request queue. Okay, initiate the request queue. So we want to start that this is our new request. And then here we have this URL, the link. So request a string response from the provided URL. As you can see, I already commented this line. So this is the line that I define. I want to get a string as a response. Okay, string request, request method, get. So I request for the string as a result. And then display the first 500 character of the response string. This one is the request under this string. Okay, what you want that together with this string. So this one is the string request. Okay, next we have this URL. I know you know what is URL because we already touched this part on, I don't remember, but I did remember we already covered URL, URI is like a link. So uniform resource locator. Okay, what is URL? I know you know URL is like a link. So this one is our example. These two is our example. URL is like an address to a web source. Okay, address. So URL is a link. Link is like the address actually. Link is the address to our web source. So next we have this second function, next function where we can cancel the request. But before we cancel the request, of course, we need to send the request first. Okay, so for example, here, this is an assumption. String request, we already send the request, like I said just now, before we cancel, of course, we need to send the request. The request must be sent first before we cancel any request. So assume this is our request, string request, and then request queue. Okay, assume this is exists. So set the tag on the request. Okay, string request tag. We need to put a tag on our string, and then add the request to the request queue. Queue the list in our request. Okay, so this is, as you can see, stop function. Cancel. I want to cancel this request that I sent up here just now, that I sent previously just now. So protected fun on stop function, cancel the request. So on stop and then request queue, cancel all. But you need to state which request that you want to cancel or you want to stop. That's the purpose of the tag here. Okay, you need to state which tag, which request that you want to cancel. But of course, the request that you send, the request that you want to cancel must be in the queue. Or in other words, that request that you want to cancel must be sent first. It is in the queue of requests. So here we have request queue. Okay, so basic request queue. Queue is what's the easy word for queue? Line? Is it line? Yeah, is it line? Request line. So needs a cache and a network. Cache here, it is same with our computer actually. Cache, it will hold our information temporarily. Okay, so if you never clear your history or never clear your cache, by right, if you go to, let's say if you go to website, they will have this cache your information. Okay, so you can see actually if you have this cache in your browser on the setting. So use the basic network and this best cache. Okay, this best cache, that means they're going to store your information temporarily at the cache. So this best cache, okay, I use this best cache to store this data and then set up the network to use HTTP connection as the client. Okay, so here I declare my network, basic network HURL stack. Request queue. Okay, so this one, initiate the request queue with the cache and network. So start the queue. The first one, we need to start the queue. Next, this is our URL, our address. So this is the step how you're going to handle the response that you receive. Case of request queue. Request queue. Queue is like what's easy word for queue? Anyone? Queue is like a line. Yeah. What come first? What request come first? What request come after the first request? Yeah, it's like a line actually. Queue. There's one term for this one, but I forgot request queue. So add the request to the request queue. So this one is the last step added into the queue. So if your app max this one is singleton pattern. This one is a pattern where we restrict the instantiation of a class to one single instance. Okay, that means we only create or we only restrict to one single class. So if your app makes constant use of the network, set up a single instance of request queue. So implement a singleton class that encapsulate the request queue and volley function, the request queue and the library. Okay, for this pattern, it can only or it will be only restricted to single instance for this queue. So this is my class, my singleton constructor. So here we have this static object, companion object, and then this is my value, my instance. Okay, it's my singleton. So when we have this concept, pattern, when you have this pattern, that means we can only create one single instance. Okay, instance is equal to my singleton. So one instance restricted to only one instance. Okay, so this one is only a function. Bitmap. Okay, so this is the process. The process for this class image loader. So here is your constructor for your class with the request queue. So application is key. It keeps you from leaking the performing request queue operation. You request to your request queue. Call the string request. You pass the string request into am I disconnected? And dispatch. The line here is not reliable at all. Let me check my slow. So here JSON request. Okay, JSON request. Just now I said JSON request and JSON object for array and object. This is under this class. Okay, they are under the same class. So the same basic pattern you use for these two type of requests. So JSON object request method here. The function here is to get URL. Okay, so respond to this request, and they're going to return to you in string. This one is for JSON object request. JSON object request, where's array? So here they only use this one function, okay? JSON object request. yeah, JSON object request into string here. This one is the error. So access the queue through your class. So access through this queue, the queue that I have through this class, which we have not only this one, but the JSON array request and JSON object request are under the JSON request class. Actually, under JSON request class, they have a few more other than these two. But here we only have these two. Okay, so that one is for JSON request. So up to this page, is there any question?
No.
Yeah, the campus line is so bad. So if no question, can we have a break and we will continue around 11:15 a.m. Sorry, 10:15 a.m. Okay, see you at 10:15 a.m. Thank you. So hi everyone, let's continue. Okay. Mm, 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 mm. This one is a protocol, MQTT. We use this one as one of the protocol in our network here for mobile application. So MQTT stands for Message Queuing Telemetry Transport. Okay, so TCP/IP, TCP/IP, and then it is a machine-to-machine connectivity protocol. Okay, so like I mentioned just now, MQTT is a protocol. So it used for machine-to-machine connectivity. I've explained what is machine-to-machine connectivity. Machine-to-machine connectivity. Yeah, machine-to-machine connectivity is let's say I have two devices and I want to have a connection between communication between two devices, machine A and machine B, or device A and device B. And of course, for this communication, I need to have a connection first. So we use this MQTT as this connection for the communication between the machine. So here is an example. It's not an example. It is like an explanation. So here, machine to machine, like I said, device to device. Okay, so here my machine is the first one, temperature sensor. Okay, we can consider this temperature sensor as our machine. And then we have the device here, the machine, laptop and the mobile device. Okay, so I need to have a protocol. Like I said, machine to machine communication is a communication between one machine to another machine. But before we go for this communication, of course, we need to have a connection. So this connection, we will use MQTT for the network. Okay, so temperature sensor and a laptop. We need to pass data from this sensor to this laptop and mobile device. So here, we have temperature sensor. So we want to send this information or this data from this sensor to mobile device or laptop here. And here we have MQTT broker. So this MQTT broker is like actually a middleman. Yeah, MQTT broker is like the entity that enable the client to communicate. Okay, it's like a platform. For just now we have back end and front end, right? So it is an API. So for this machine to machine, using this MQTT, we have this broker, MQTT broker. It's like a middleman, middleman. Okay, so they will process and they will publish. They will send the information to this laptop and this mobile device. Okay, so basically MQTT is a protocol for the connection between machine to machine. So here we have 2 points here. Subscribe to topic, temperature. Okay, so this is the data, the information that I want to send or I want to share from machine A to machine B. So this one is the first one, subscribe to topic, temperature, the data. And then the second one is I am going to send this data, this information, which is temperature here, publish to topic, temperature. Okay, I am going to send this one to the other machine. So we have sensor and we have this receiving machine here. So this one is actually, I remember during my degree, this is my project for my mobile application. We are using sensor and we are using machine. We capture information about the weather. Last time we're using weather. We capture the weather information using the sensor and we get the information using our machine. And of course, like I said, we need to have this network protocol. So here is MQTT. Okay, so this one is for your additional knowledge, introduction to MQTT, Eclipse for Android and Kotlin implementation. So we have client and we have Android app that use MQTT. So why MQTT is a suitable network protocol for a mobile app developed to communicate with IoT devices. IoT devices For example, just now in patch 41, right, we have sensor. So sensor can be considered as IoT devices. What is IoT devices other than sensor? For example, last time I mentioned about the robot, the vacuum cleaner, the robot. I forgot the name. And then the cartoon, the BMX. BMX, that's example of IoT. IoT is any device that we connection or anything that we apply the technology into it. For example, the vacuum, we apply the sensor into the IoT, sensor into the vacuum. Okay, so why MQTT is suitable network protocol for mobile developed to communicate with IoT device. Anyone, why do you think it is suitable for our mobile application? Anyone? Yeah, Romba. That's the name again. Last time you told me also Romba. The Romba is the example of the IoT. Romba, sensor, the BMX, what else? Actually, there's a lot. Your smartwatch can be considered as IoT too. Smartwatch is, yeah, smartwatch. So why do you think it is suitable? Wait, let me find some proper answer first. Hi, what? So here, the first one here is can connect to many devices. If you refer to page 41, okay, so we're using this machine, okay, so we can actually send all the information to many devices. That means they have no limited number of devices that can connect or that can get data from the sensor or machine. And then the second one is high compatibility. Okay, that means less setting work for us to do. So this is the answer, suggested answer for this question. Can connect to many devices and high compatibility. Next is mobile server option. Same with web test, same with system, same with application. Okay, we have a server. Server is basically where we are going to keep the DB, for example. So mobile app serve the UI or front end. Mobile applications serve as the UI or the front end. Yes. What's the point of this first point actually? Of course, mobile apps serve as the UI or the front end. Okay, what the user see. So backend provides DB, script, API, and the architecture of the app, which is the connection DB to the app. So this is the example of the process at the backend. Like I mentioned, we have this networking, the DB, the connection, everything as the backend. Okay, so there are three main core function: application server, the web server, and your DB. So here is the popular backend technologies. Okay, Ruby on Rails. Ruby is one of a programming language, high level of programming language. Okay, honestly, I never use Ruby. I don't even know how to write in Ruby. Okay, so it is a web application development framework. However, I know Ruby is a high level programming language. And then Express KIA and Cells, a web application framework for Node.js, JavaScript, Django. Django 2 is a language. So it is a high level Python Python is a language to web framework. So PHP model view controller framework, and then Google Firebase. So this is the technology or the framework that we use for our mobile application. So here we have 3 options for our server. Yeah, so the first one is DIY. We build our own server. Yes, we can create our own server, but to create our own server, to build our own server, we need to have knowledge. Of course, we need knowledge for each of this, but we need to have more knowledge because we need to create our own server. So here for our own server, we need to have this API. I expect you know what is API already, the platform, the method, how for the communication, and the DB, the database. Okay. So this one is, there's a lot actually. Yeah, there's a lot as the service, the BaaS, DB, AI, one area of knowledge in computer science. Same with IoT, Internet of Things. We have AI. What is AI? Who should I ask? Alvin, Daniel. Daniel, I think you read a lot. What do you think AI stand for? Anyone? AI? Dr. Chris, area of knowledge. AI. AI stand for, thanks Ian, artificial intelligence. Yes, artificial intelligence. Like I said, same with IoT, AI is an area of knowledge. This one is Dr. Chris punya area. I don't really do AI. Okay, so quality control and security. So mix and bang. So you combine these two, which is you do your own and then you subscribe. I think for this one, I can give you the logic. For mix server, create our own server and we subscribe. No. I don't want to give explanation that I'm not confident. I'm not sure what's the logic or how they are going to do the connection between the subscribe and the server that we built. Because last time when I was a programmer, I was the admin actually to my team. So I have all of the source code, and basically we use this one. Subscribe. We subscribe to a server and we put everything into the server. But for mix and bang, I'm not sure what's the connection. Okay, so for the first one, server options DIY. Okay, so for the first one is the DIY, the server that we need to create. Okay, so we create our own server. Like I said, this is not easy to create, to build our own server. So here you need to have this complete control. That means you need, of course, hardware. Hardware is important. Okay, if you need a physical hardware, for example, if you need to have a physical server, okay, hardware, software, any software that you need, network and service. Okay, so for this one is because we need to, any server, they will provide or they will attach, they will give to us. Okay, so need more time on monitoring and maintenance. Yeah, like I said, you need more knowledge, you need to spend more time because basically you need to do your own. If you subscribe to any server, if you have issue, if you have error, usually we call it as issue. If you have issue with your server, you can contact them. They will try to solve it for you because we subscribe to them. Okay, so this is the DIY advantage and the disadvantage of the server. So advantage, you have the complete control of this hardware, software, network, and service. This one can be an advantage, but can be disadvantage as well. Like I said, if you need specific software, so you need to have it before you can use your server. Okay. So disadvantage, heavy customization. Like I said, you need to do your own setting. You need to decide. Complexity, security vulnerabilities. Not necessarily you will encounter with this security vulnerabilities. Okay, this one we can counter, we can avoid if we perform security testing on our server. Okay, that one is another process, but I'm just telling you, we can encounter these security vulnerabilities with security testing. If I'm not mistaken, there's one test, we call it as pen test, is it? Is it pen test for security? I forgot the term. Cyber protection. Oh yeah, there's one test under this this one, security vulnerabilities pen test. Penetration testing. Yes, penetration testing. We call it as pen test. Pen test is hard to do actually, even though it's testing. And then insufficient performance, defective reliability, poor functionality, technical debt. Okay, so this is all the disadvantage. Okay, subscribe, popular method. That means we pay for what we use. Oh no, we pay for what we use is one of the method. Okay, there's many method under subscribe. So popular methods, cloud. It is the delivery of demand computing resources over the internet on a pay for use basis. Okay, not necessarily for pay for use. They have other three bases if I'm not mistaken. Pay for use is we pay for what we use, or no, that's three, but I don't remember. We pay for what we use. We pay with the fixed price, even though we don't use that amount of storage. Let's say they provide some storage for our server. We still need to pay, even though we don't use them. And then there's third one, I forgot, but there's three actually. Okay, so this one is one of the basis, pay for what we use. And then next is container. Offers a logical packaging mechanism in which application can be abstracted from the environment in which they can actually run. Visualization, process of running visual instance, best be backend as a service, delivery model for a set of tools that facilitate collaboration between organization software team and the operations team. Okay, so this one is subscribe. That means we just pay. There's a lot of provider actually. So container. So this one you may check what is container here. Okay, container is like the adapter pattern. You may go through this link. Okay, server option subscribe. We have, of course, the advantage and disadvantage. So advantage, cost efficiency. Okay, cost efficiency. We can subscribe, for example, the storage I mentioned just now. We can subscribe how much storage we want to use. Okay, scalability, the speed, integration, audit and compliance, business continuity and planning. So this one is the disadvantage. Pay, of course, we need to pay for what we use, and then the security. This one is not, even for the built-in, the server that we build our own, this issue is still there, security. Any type of server, as long as we already upload to our server, this is still one of the concern. Okay, not only under the subscribe server. So here we have service under backend as a service. We have storage, push notification, usage analytic, dashboard, integration, admin, custom code integration. So this is the example of service under the backend as a service. Okay, yeah. So this is the provider actually. So we have Firebase, Azure, Apple Cloud Kit, Alibaba, Amazon, and Huawei Cloud, a provider to this service. Okay. Last time I used this AWS, Amazon Web Service. Be careful when you use this one, because first when you want to register, they will ask you to key in like your card information. So I did key in my card information. So they deduct like dollars from my account. So be careful when you use any of the provider. Okay, so this one is the example. I'm not going to read this for you. You may go and read this yourself. This one, Fire, is one of the provider for BaaS, backend as a service. Okay. Why I skip? Yeah, Fire as a service. And then this one is for Google Cloud, Intro to Google Cloud for student developer. Okay, Google Cloud. Mostly we use Google Cloud these days. Okay, even to upload, share your lecture note, for example, the Google Classroom can be considered as Google Cloud. Why? Because I upload the lecture note or the material into the classroom and then the student download from the classroom, Google Classroom. And then this one is AWS, Amazon Web Service. Okay, in Amazon Web Service, they have a lot of function that they provide actually. Okay, so they have deployment and management, application service, and the foundation service. This is two. I'm not going to read this application for you. You may read this one for yourself. AWS. This one is quite famous actually. One of the provider. So yeah, AWS, Amazon Web Service. So next we have Azure. Azure also is top in the board actually, other than Amazon. I don't really use Azure. I forgot why, but Azure also is a good provider. So here is the process or is the service that they have. They have this process for the REST API. REST, remember REST is one of the API. Okay, so they can have this cloud storage, user authentication, and push notification. Azure. So here is Apple Cloud Kit. I cannot explain much what is Apple Cloud Kit because I'm not the user. However, I think this one same function. They are cloud provider. Okay, cloud provider. This one is Alibaba Cloud. Alibaba Cloud is basically from China, right? China. Okay, Alibaba Cloud. Again, same function. I never use. I didn't even know this thing, Alibaba Cloud. However, here they have function, same function actually. This one is the standard service that they have, user center, store center. Okay, and then Aliware Enterprise Class Internet Architecture Platform. Yeah, Alibaba Cloud. These two I cannot explain much, Apple and this Alibaba, because I'm not the user to any of them. And then Huawei. Huawei also come like Google. They have their own cloud service. Okay, so they have VM, virtual machine, Metal, public cloud monitoring, security as a service, AAS, security as a service, database as a service, storage, and the network. This is basically under Huawei. And for your information, Huawei is like rebuilding the product. They will come up with a new, not necessary device, with a new service. If I'm not mistaken, no, they already provide like their own store. So this one is a question. Okay, for this question, I won't ask you today because you have tests. I want to give you time to prepare for your test for the afternoon session. So for question 1 here, compare subscription-based and traditional DIY server solution for the mobile app. So just now we have like a comparison, okay, between the 3 DIY, the one that we built ourselves, the subscribe, and the mix or the mix server. So this one is H&H is the Malaysia's largest car parts supplier. The company hires more than salesperson to sell the products. Currently, the company operates a web-based inventory system. I know many of you like this system, inventory system. So H&H team need a mobile solution to solve such function. And then second, inefficient territory management. Okay, propose a new feature include the push notification and chatbot. Chatbot is one of the example of the, excuse me, chatbot is one of the example of AI just now, artificial intelligence. So suggest a way to deploy these features. To deploy these features in the most secure and cost-effective manner. So this one, I leave this question as your homework. Okay, so that's the end of chapter 4. Yeah, that's the end of chapter 4. So for chapter 4, 4.2, is there any question?
No.
Okay, so let me stop the recording first. If no question, that's the end of that's the end of our lecture for today. So in the afternoon session, don't leave first. Okay, so for your practical test, excuse me. So for your practical test, can you go to our Google Classroom? Can you see? Can you see our practical test section in there? So, okay, wait. So this afternoon, later, yeah, please check the practical test there. Can you see the part in there? Practical, can you see or not? Please do let me know. Submission post. Can you refresh? I'm going to post the question in there. Okay. Submission post. Yeah, you don't have to say that, Ian. Okay, so during the afternoon letter, you will get the question from that part. Okay, so please check and please do let me know. Yeah, you guys, luckily I already stopped the reading. So your test will be from 1:30 to, sorry, from 1 p.m. to 3 p.m. Okay, so no practical session. Instead, we will have our practical quiz. However, you still need to join our Google Classroom. Okay, so no more question, right? Or is there any question before we dismiss? So if no question, I think that's the end of our session this morning. Thank you, everyone. See you this afternoon. Good luck for your test. Bye-bye.